There's been a lot of discussion in the industry about whether large language models can actually think, or is it just an illusion of sentience? Well, frankly, this debate seems outdated, because when we look at the large language models that are being innovated today, they are doing sophisticated reasoning. They're using techniques like self-critique, chain of thought analysis, and complex logic to fine-tune their responses, be it a pixel, a piece of text, or even entire lines of code, blocks of code. This isn't just a small iterative evolve of a large language model. These are giant leaps that these models are taking as they become more and more sophisticated. As we think about the evolution of large language models, we actually see that large language models are moving from beyond just the model itself to actually an agentic system, a system that can act. And that means not just a large language model on its own, it's a model combined with tools that help it act, combined with context, combined with additional knowledge that it has access to in real time. And it isn't just theory. If we look at some of the innovators in this space who are already putting these agentic systems to work, they're seeing results. So Bud Financial, they work with fintech companies and banks. They implemented an agentic application called Drive that gives their clients access to customer insights. That Drive application also creates specific personalized customer actions. And through that application, they're seeing a huge boost in customer engagement and a 20% improvement in offer uptake rates. This is what happens when you build on an agentic system. But what is an agent? Well, there's lots said about agents, so let's get super precise. An agent has to have tools to act. It needs memory so it can learn and it can recall that memory during conversations. And it needs context so we can trust the agent. So let's take a deep dive into each of these three areas to understand the innovations that are taking place and what you can do today. So first, tools. An agent has to be able to do things. And to do things, one of the biggest unlocks has been the ability to train agents to be able to use tools, to interact not with just one tool, but a series of different tools. In fact, when agents start to interact with tools, they're no longer just a passive knowledge base of information. Now they can be part of a workflow. Agents that don't use tools or LLMs that don't activate those tools struggle with problems that require rigorous, verifiable reasoning. Whereas if you look at, to give you a concrete example, geometry problems. If you asked an LLM to do a geometry problem, solution it, and create a proof, it would create the proof. That proof would be based on proofs it's seen in its training data set before. It would compile it, it would look very elegant, but it wouldn't be based on logical reasoning and deduction. So it would most likely be wrong. Whereas if we look at models like Gemini DeepThink, they are now able to do those complex geometry questions. In fact, Gemini DeepThink won the gold medal at the International Mathematics Olympiad this year. And the way that Gemini DeepThink was able to solve those problems is because it starts to mimic how humans solve problems. It uses parallel thinking. So it comes up with multiple potential paths, solutions for those paths, and actually the final answer is often a combination of those different paths and solutions. It also starts to activate tools that we've trained it on. Things like deep reinforcement learning. It activates a corpus of mathematical solutions that we've given it. And it's that combination of parallel thinking, advanced reasoning, and putting to use practical tools that allows the model to go beyond to deliver this breakthrough. Now apply that same context in the world of data, because in the world of data, we're trying to do workflows all of the time, and these are complex workflows. Well, today, we've got a data science agent that is able to help put together those workflows. But now that data science agent can also use tools. So in fact, we've trained our data science agent to be able to use BigQuery machine learning and AI, so it can do analytics and it can do inferencing. It can actually activate Spark libraries to do large-scale data transformation, and it can even use BigQuery data frames for large-scale Python processing. So instead of it just being a simple SQL or Spark engine, now you have a data science agent that can create these complex workflows, creating on top of these engines. And how does it all come together? Well, in our Colab Notebook experience. So today, if you visit our Colab Notebook, you can activate this agent, and it will start to create different cells. SQL cells, visualization cells, Spark cells, as it creates these workflows using these multiple tools. And you will see the Colab Notebook in action in our demo in a little bit. Now, to make this orchestration super powerful, it's not just about having the standard data stack. We've actually had to redefine the data stack. Because if we want these agents to be able to use these tools need to be built, embedded AI natively into the data stack. So at Google, we've been working on redefining what the future data stack is, launching various tools within the data stack so that these agents can operate on top of the data stack natively with AI. A set of these tools that we recently launched were AI operators. AI operators aren't just a model inside a data stack. They're actually AI functions that are integrated into the data stack. So you can do things like unstructured data processing. You can bring real-world knowledge into your analysis. So for example, say you wanted to run sentiment analysis or classification over voice files, over text. You can now do that with AI operators. You can also take your product catalog and combine it with competitor information by using the real-world knowledge embedded within these AI operators. This opens up a huge amount of possibility of the types of questions you can now ask within your data stack with these new types of tools. So analytics and data science was just one example. We're applying this across various parts of the data workflow. So imagine a data engineering agent that can now build data pipelines and verify the data that is flowing through those pipelines. Or say a conversational analytics agent for business users that can connect to an ads API and pull through data, combining it with sales and revenue to get to ROI information in merely minutes. These are agents in the data world that are available today. Okay, so we spoke about tools and giving our agents the ability to use those tools to act. So let's look at that second pillar, memory. The ability for an agent to learn and recall that information when they're having a conversation. Now, this one is really important because if you don't have memory, actually, it feels like you're speaking to an agent with amnesia. It doesn't recall anything. So we think about memory in two ways. There's short-term conversational memory, and then there's long-term enterprise knowledge memory. So let's think about short-term memory. So if I'm interacting with my agent and it's not remembering the last sentence I said or the last few sentences, it's really frustrating. But over time, if you've had multiple conversations and it remembers nothing, it's increasingly frustrating for users. So solving for short-term memory today has been, there's been a brute force approach of let's take the conversation history, stuff it into the context window, so anytime you're asking a question to the agent, it has that context and it can answer that question more intelligently. But that brute force approach is not very elegant, because as that conversational history increases and you continue to stuff it into the context window, we actually see the LLMs begin to produce wrong answers. The answers don't get more intelligent, they in fact get less intelligent. Because all of that context has noise, the model starts to find it hard to differentiate where the signals are. So this is why we launched the Vertex Memory Bank. What happens with the memory bank is anytime you're having a conversation, the memory bank is pooling key characteristics from that conversation and storing them. So does this user prefer to sit in a window seat or an aisle seat? It will extract those user preferences and store them in the memory bank, so in the next conversation, the agent can pull details from the memory bank to engage with that user again. This brings us to long-term memory. So that short-term memory is great for conversations, but now how do we give agents access to your multi-year, multimodal data? Think of your business. You have years of data, petabytes of data. How do we give access to a model to all of that data? Well, one of the initial approaches that emerged was fine-tuning a model on your business data. But that actually doesn't really work. Think about if I fine-tuned a model today on my inventory data. If I ask a question on that model this evening or tomorrow, it's wrong because your inventory levels have changed. Your business is changing all of the time, so just fine-tuning doesn't work. The brute force approach doesn't work because it's mathematically impossible to stuff all of your business data into the context window of a model. So this is where vector embeddings and vector search is key. Being able to index your data with vector embeddings and providing your agent with a vector search capability to access that data in real time. It's basically giving it a real-time connection from your agent to your data platform. But the key here is those vector capabilities can't be a separate system. They have to be built into the data stack. So again, we have to redefine the data stack. So today at Google, we've built all of those vector search and embedding capabilities into our leading operational analytical platforms like BigQuery and AlloyDB, so that those platforms can serve all of that data back up to agentic systems. Let's take Morrison. They're a great example. They're one of the UK's largest supermarkets, serving 10 million customers every week. They had a business challenge. On the shop floor, their associates would commonly get the question of, where can I find this product? Imagine how frustrating that must be. So they created a new feature in the Morrison's app called the Product Finder. The Product Finder has that real-time connection to Morrison's inventory and store layout data, so that in real time, it can answer that question for customers. So when a customer asks where a product is, it's real-time looking up the store layout, inventory levels, and giving the customer an accurate answer. So this search is already running 50,000 searches daily as customers use this new capability. So this is the vector search capability as we bring that into our data platforms, giving models that deep access to data. Okay, but speed is important. So both in that short-term memory example, where we're looking for personalization attributes, or in the long-term memory example, where we're grounding our agents with your data platform, the speed at which these data agents respond is actually really important. In fact, what we're seeing in the agentic world is it actually needs to be even faster than the traditional world we've known to date. I wanted to show you a video that brings home why that speed is so important. So in this video in a moment, you're going to see a human ordering food through an app, and they're just using the normal app, thumbing through selecting items, and then you see a voice-activated agent where it's a human speaking to the agent doing the same task.
Can I have a classic cheeseburger, add avocado and pickles?
Would you like to make it a combo with a side and a drink?
Yes, make it a combo with fries and a Coke. And can I have a kid's grilled cheese with yogurt and milk? Oh, and add an order of onion rings, 2 orders of mozzarella sticks, and a brownie. Actually, change the brownie to a crumb cake. And remove the pickles from the classic cheeseburger. Okay, that's it.
Okay, you see the difference there. The voice-activated experience has completed in 33 seconds. And the human experience, once it completes, you see it takes 89 seconds to complete that end-to-end experience. So these new voice-activated agentic experiences actually let humans move much, much faster. But the implication of this is our data platforms, our analytical operational systems underneath, also need to be able to move at that speed that we see the voice-activated agents moving at today. In fact, I'd finished my talk track for this slide and it's still not completed that 89-second journey. It just shows what the difference, what difference it makes with that 56-second gap. Just imagine in that Morrison's example, if the product finder was slow by 5 seconds, 10 seconds, the user feels a broken experience. In a voice-activated world, a 5-10 second delay means a user has abandoned that experience altogether. So this is the importance of not just having the memory for these agents, but also making it real-time, making it hyper-responsive. Okay, that takes me to my third pillar. So we now have agents that have tools where they can use those tools to take action. They have memory, so they have understanding of that user, and they have access to your business data. So it brings us to context, because all of that is great, but not so great if I don't feel like I can trust my agent. And this is where context comes in, because trust has been one of the foundational blockers to more faster adoption of AI and agents. How do I know I can trust my large language model? And in a business context, it's quite hard, because a large language model doesn't know your business rules. In fact, you've got millions of columns of data, tens of thousands of tables. That's what my average customer tells me. Hey, I've got massive data platforms. How does the agent decipher between all of those data tables? What is the golden source of customer information? It doesn't understand your business rules, which are often not encoded within an easily accessible location for the agent. So this is where the knowledge engine comes in. And it was mentioned in the earlier talk by Mike. How do we build these knowledge engines, knowledge graphs, so that we can give agents that context? So at Google, we've been building those the knowledge engine, which essentially extracts all the metadata about data, extracts business rules, extracts semantics from the data platform, and it builds a knowledge graph that allows an agent to be grounded in your business context. So when you say, I want to know how many active users we have, it knows exactly what the definition of active user is. In fact, let's just use a healthcare example. Say I asked, what is our current readmission rate for cardiac patients? If the agent wasn't grounded in this knowledge engine, it would calculate that readmission rate based on all of time, all of history. Over the last 30 years, have we ever seen this patient come in again? Clearly, that is a wrong answer, because readmission rates are classed as, has this patient been back in over the last 30 days? So having those business rules, that semantic context encoded in the knowledge engine, allows the agent to be smart with its answers when you look for those business questions. Okay, so we've built these powerful, trusted agents that now have tools, memory, context. But actually, it's not about a single agent. What we see the future being is actually a fleet of agents working together to solve end-to-end business problems. Actually, those fleet of agents really bringing down that time between opportunity and action. But to do that, and to have this fleet of agents, all connected to various tools, all connected to various data sources, now you potentially have an integration nightmare. This is why you see new standards emerging in the industry, be it the MCP protocol, the agent-to-agent protocol, the agent developer kit. These are protocols and tools to help build this future around multi-agent systems. But rather than tell you more about this, let me go to a demo to show you how all of these systems work together. So in this demo, we show 3 really powerful capabilities. First is a single-shot way of now processing unstructured data. Second, we see real-time continuous queries. These are real-time streams that are analyzing the incoming transactions and triggering alerts. And the way it triggers alerts is through this proactive, event-driven set of agents. So we're going to take receipts, transactions that are happening, process those receipts through a real-time query, have that real-time query activate a set of agents, and then potentially create a ServiceNow alert if something looks suspicious. Okay, so in our demo here, we start in our Colab notebook experience I spoke about earlier. This notebook allows us to combine all languages of code, visualization. You also see unstructured data, a receipt. Now, previously, getting information out of that receipt would have been hard, but now, through a single line of code, we can extract all of the details from that receipt into clean JSON data ready to be analyzed. This is that single-shot unstructured data analysis made super easy with those built-in AI operators. Next, we're going to have a look at this real-time streaming query. This is processing those transactions that are coming in. Let's ask Gemini to explain what this real-time streaming query is doing. So Gemini tells us that actually this real-time query is not just analyzing single events. This new real-time capability we're launching today does stateful analysis. It looks at multiple events in sequence and looks at, does that sequence of events look suspicious? It's not just that it was one £5 transaction, it was the fact that there were 20 £5 transactions in the space of 2 minutes. Something looks suspicious. Okay, so let's ask Gemini, hey, I want to know how many transactions are we processing? Here you see our agent actually writing code to understand how many transactions there are, and then building a visualization direct within our notebook. So we can see all of the transactions that are being processed. And as I mentioned before, it's not just creating a fraud score. As part of this real-time query, it's activating agents. So let's take a look at those agents in action. So we're going to switch over to our agent developer kit. This is where we've set up our agents. So let's ask, hey, agents, what can you do for us? And they come back pretty quick there. 4 different agents. There's a search agent. It's actually searching the merchant to understand on the web, does it look like a real merchant? We have an investigations agent that is looking at the history of that customer's transactions to look at other suspicious patterns. We also have a multimodal agent that is analyzing the receipt to look at, does it look like it's being faked? Is it fraudulent? The final agent there is the decisioning agent, and you see it here. You see that the decisioning agent has access to multiple tools, and it's orchestrating all of these agents, not in a linear flow, but actually doing iterative reasoning. Okay, so we're going to give these agents our JSON data from our earlier receipt and ask them to analyze. And you see the agents, they start to iterate. This is all usually happening in the background. And they're analyzing the web search agent, the investigations agent, the multimodal agent. And if they suspect it's suspicious, it's going to create a human alert. And there you see, it's created a ServiceNow ticket. That ServiceNow ticket, if we switch on into there, we can see that the agent has pre-populated the entire ticket with detailed information, including the risk score, including information telling us, hey, the merchant looks suspicious, the receipt looks like it's been faked, it looks like there's a set of suspicious transactions here. We can even take a look at the receipt in ServiceNow, and actually the agent is recommending that we freeze the account and notify the customer. So now the human has access to all of this information to make quick, fast decisions in minutes, not weeks, in a lengthy investigation. This is the power of unstructured single-shot analysis coming together with real-time, stateful real-time queries with these multi-agent systems, now being able to automate entire workflows. The world is changing. These agents, defined by their ability to use tools, leverage memory, context, are able to do things we couldn't imagine before. And at Google, we're building all of the kit. We're building the protocols. We're building the fast memory, the knowledge engine, so you can focus on innovation as you bring these things together to solve business problems. And for us, we imagine a world of not just solving one business problem with one agent, it's a fleet of agents that actually enable the future autonomous enterprise where both back office and front office use cases are being transformed across the enterprise. So everything I showed you today helps take away that drudgery. Whether you're a data scientist, a data engineer, a business user, we can now focus on the high-value business impact instead of spending hours doing data engineering or pipelining work of trying to wrangle together unstructured data. So today, the question shouldn't be, how do I use AI? The question is, how do we make enterprises truly think through these new agentic experiences? Thank you so much for joining me this morning. It's a pleasure.